Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I'm going to take a deep dive into the multi-banded point cloud import operation in ProRaster Scientific. So there are 3 videos that you should review before you watch this video. I did a very brief introduction to how to import LiDAR point clouds. I did a brief introduction video on how to import multi-banded general point cloud data. And I've done a deep dive into LiDAR importing. Now, LiDAR and multi-banded point importing are both pretty similar, so you should review all of those videos before you watch this one. So I'm going to go fairly quickly. So to import multi-banded general point cloud data from ASCII files into an MRP point file, which you can then use in ProRaster Scientific to display huge point clouds, and then to grid huge point clouds in real time, go to the point processing menu, drop that down and select import multi-banded points. Across to the right you'll have some options here. So the top option, import multi-banded points, will initiate a new import operation, and that will open this dialog. Now, just like LiDAR, after you run your import operation, it will create an XML file, which will have the same name as the output MRP file. And then that XML file will be placed onto this drop menu, and it will appear in this list here. That gives you the opportunity to go back to that operation and to do one of 4 things. 1, you can completely repeat the operation and do it again with some change parameters if you want to make some changes. Or secondly, you can go back and add more data into an existing MRP file by running the operation a second time and choosing new data to add into that MRP file. So if you have ASCII point data files that are in 2 different formats, for example, you can import all the files that are in one format in the first execution, and then go back, run the operation again, select the files that are in the second format, change the import parameters that you need to do to recognize that format, and then run it again, and it'll add those points into that MRP file. So that's how we operate through that import loop. So let's take a look at this dialog. Firstly, we're going to select ASCII files. You can select all of the files of a particular extension in a folder. So CSV, DAT, XYZ, just some standard ASCII file extensions there. Hit this button to choose a folder and to choose all files of that kind from the folder, or you can browse for ASCII files and just select multiple files. You must create an MRP file, so you have to define the MRP file name. You can either do that by dropping down this list, and it will show you MRP files that you've created in the past, and if you want to replace one of those, you can select one of those MRP files. Or you can browse to an MRP file or type in an new MRP file name. Now, if you are editing, you will want to set this temporal storage mode, and I explained this in the LiDAR video. So there are 3 possibilities: accumulate, accrete, and repeat. Now, most of the time you're going to use accumulate. That means that every time you run the import and accumulate more data points into an MRP file, you're just stuffing all of those points into the same bucket. And at the end of the day, there's no distinction between any of them. That's accumulate mode. Then there's accrete mode. Accrete allows you to add temporal events into the MRP file. So you get an extra dimension in your MRP file, which is time. So every time you import data, you will accrete more points into your MRP file, and they're stored separately to any existing points. And then when you work with that MRP file, with that point file in ProRaster Scientific, you can see those points by event, or you can combine events together to combine points, and you can do that in gridding and so forth as well. And then the third mode is repeat. This is designed for a scenario where you're repeatedly surveying the same area. So for example, it might be a coal mine that is repeatedly surveying an ore stockpile to see how that stockpile is changing over time, and to measure the volume of that stockpile as it changes over time. So that's a repeat survey of the same area, and in that case each event is treated completely separately by ProRaster. So you can see the points from each event, and you can grid the points from each event, but you can't combine points from multiple temporal events. So that's our temporal storage mode. In the LiDAR system, the temporal event time is picked up from the LiDAR file itself and is set automatically. That doesn't happen in the general multi-banded point import, so you'll need to press this button on the side here to set the event time for the MRP file each time you import more points into that MRP file. So you set the year, month, and the day, and the hour, etc., and that will set the time. Down here we have our MRP properties. So we have our name. So this is cosmetic. That's just the name of your data set, and that will appear when you drag and drop the MRP file into ProRaster Scientific to visualize it, for example. You can choose some metadata to store into the MRP file. So this will come in the form of an ASCII file. It might just be pure text. It might be in XML format. Whatever it is, it's just ASCII. And the entire file will be copied into the MRP file for safekeeping. So for example, you might have some file which describes the survey that you've conducted, all of the parameters and information about that survey. It's just a simple ASCII text file. You can put that in, browse to it, select it, and put it into your MRP file where it's stored for all time, and then you'll be able to see that when you go into things like the raster source editor and get a report on a file. You'll get all that information printed out in that report. So that's your metadata. You need to set the coordinate system. Again, in LiDAR, we pick up the coordinate system from the LiDAR files itself. That doesn't happen in multi-banded point import. You must select and specify the coordinate system. And it's a little bit different from the LiDAR system because we do support reprojection of those coordinates from the coordinate system that they're in the ASCII file into the coordinate system that you want for your MRP file. So in here, we're specifying the coordinate system of the MRP file, so I can select one that I've used before, for example. And or I can go to the coordinate system, the projection editor dialog, which isn't coming up right at this moment. Oh, there it is. And you can come in here and select, some coordinate system. Okay, so that's the coordinate system of the MRP. When you specify your ASCII input files, you will also specify the coordinate system for those files. So the X and Y coordinates in those files will be in that coordinate system. If your coordinate system in the MRP file is different, then those coordinates will be reprojected from the ASCII file coordinate system into the MRP coordinate system in the import process, and at the end of the day they'll be stored in the MRP in the coordinate system that you specify here. If you have a Z channel, then you can specify the vertical units of the Z channel, whether it be meters or feet. There are some other options. And you must specify the cell size. So you can specify it as a decimal, and this is X by Y, and of course our cells will almost always be square. Or you can set it as fractional. For example, I can set it as 1 on 3/600, which if I was working with a geographic coordinate system latitude and longitudes, that would be 1 arcsecond. So there's two ways there of specifying your cell size. So as I've discussed before, the MRP file requires this cell size so that it can define the size of a tile, which is 256 by 256 cells. And you want to choose a cell size that gives you about 1 point per cell, something like that. And so this is this is quite a critical choice. If it's too small, then you'll have efficiency issues. If it's too large, you'll have efficiency issues. You do want to get it in the sweet spot. If you have a survey, which is a line-based survey, typically where you've got lines that are a fair way apart, and then you've got stations along the line that are quite close together compared to the line spacing, and then you might have tie lines that are at an even greater line spacing. Well, then you can use this little cell size calculator to work out a decent cell size for your MRP file. So if I had a line spacing of, say, 200 meters, and then my tie lines were at 10 times that, so at 2,000 meters, but my station spacing along the line was only 2 meters, then it's suggesting here that a good cell size is 9.53. It's just giving me a decimal cell size. I would choose something like 10 instead. And it's also giving me some line spacing related cell sizes that are going to be good numbers for when I do minimum curvature gridding of that kind of line-based data. So, you might want to take notice of those as well. These are all good suggestions. You'll take one of these suggestions for the cell size. Otherwise, if it's randomly spaced data, then you're going to have to work out what that point density is and what an appropriate cell size is for that data. And as we talked about before with LiDAR, cell size is usually about, half a meter or a quarter of a meter, because that point density is very large. With your multi-banded point input, it's usually going to be larger than that because you won't have the same kind of point density that you get in a LiDAR survey. So let me cancel all that and we'll do an import. So start from scratch. And I'm going to choose a file. So this is some line-based data. My data file is a .dat file. I'm going to choose that. So I'm going to specify my output file name. So we'll make this demo magdemo.mrp. There's one. We'll call it that. I'm going to accumulate points to a single event, and I might know when this survey was. It was in 2019 on April the 15th. So I'll set a time for that one event that's going to be generated. This is P574, I think. TMI survey. XML metadata. In this case, I do have some metadata. This little DFN file. The DFN file in this case defines the columns in the ASCII file and the null values that are used in each of those columns. So I can just use that and put that in as my metadata. My coordinate system, let me just check if it's in there at all. I'm not sure what that is, so I'm going to go with, I think it's probably zone 50. We'll go with zone 50. So I'm going to have a projected coordinate system. My vertical units will be meters. I'll do my cell size calculator. So my line spacing I think is 400 and 4,000. Long line spacing is about 8. So it's telling me at 1/5 of a line spacing, 40 is a good choice. So I'm going to use 40. Now, it can't import the ASCII files without some further information. You have to link all the columns to the bands in the MRP file, and you do that by hitting this button here. In this case, we have no header rows, so I'm not going to skip any header rows, and I don't have any band title rows, so I'm not going to load that up. And if I look at the preview, it's just column delimited data with spaces as the delimiters, and that DFN file describes what these columns are. So I want to create a band in my MRP file for each one of these columns. So I can still hit autofill, and it creates a band for each one of those columns. Now I have to tell the system what these columns are. So I'll go back to this little file, and you can see here that that the second last one is longitude. So that's band 8. So that will be the X band, and I have to identify an X and a Y band. Z band is optional, and everything else will be a data band. So I'm going to call that X. As soon as I hit it, it puts it to the top, and I'm going to call this, now I'm going to reproject, so I'm going to call this easting. And then that that last band was latitude, so I'm going to call that Y, and I'm now going to call that northing. And then we have all these other bands. So this one is, I'm going to rename all of this. That's line, flight, level, flag, line type, bid, and I should just be copying these out of here, shouldn't I? 3 magnetics channels, so there's my band names. Now, if I don't want some of these bands, I can hit this delete button and delete the highlighted line or multiple highlighted lines. I can also reorder the lines. Simply grab the line and drag it around, and you can reorder it. Over here, we see a preview of what value is coming out of the ASCII file. We've got our column. Everything's looking good. Now we need to set the data type, and that's in this drop list here. So X and Y will be double precision values, 8-byte reals. So we'll use 8-byte reel. So line is going to be I'm going to use a 4-byte integer. Flight is going to be a 1-byte integer. The level flag is going to be a 1-byte integer. The line type is going to be a 1-byte integer. Fiducial is going to be an 8-byte integer. And my 3 magnetic channels will be 4-byte reals, so they're floating point numbers. Finally, I need to identify null values in these columns. And you can see in this file that there are numbers listed for the null values. And the way that we do that in this importer is we set up a data conditioning filter. So over here on ProRaster dialog, maybe I'll open up another one so we can see. Here's another instance of ProRaster Scientific. Here's our data conditioning editor. So this allows us to create these little filters that turn data values into null values. That's its primary purpose, to turn values that you identify as being invalid values into an invalid specification. And it can do some other things as well. So once it's turned something to a null value, it can then convert it to a background value, or it can cap values to minimum and maximum, or you can apply a transform. But in this case, I'm just going to define, and I've defined these manually myself, some simple rules that identify the null values. So here I've got a null value for real 8, and I've taken this number here, minus 9999 e to the 32. I've pasted into this value list, and I've added that value to this list. So the filter is going to look for those data values. If it finds it, it's going to say that's an invalid value, and that will be stored into the MRP file. So the MRP will still store the data value, and it'll still store the station. It won't reject the station, but the value will be flagged as invalid. And so whenever you're rendering or gridding or anything else, those systems will be able to identify those values are invalid. So I've set that up for these various things in this file. And now I can use them in this drop list. So I come in here, and here are my DC filters. So I'm going to choose null real 8 for easting, null real 8 for northing because they're double precision values, int 4, just choose the appropriate filter for each one of these. Of course, you might not have a filter, you might not have any values that are going to be invalid, but in this particular data set there are values that are invalid, and if you don't mark them as being invalid, then they're going to do two things. Firstly, they're going to stuff up your statistics because you'll have these outliers. Secondly, if the null values are sitting in your X and Y, then it's going to stuff up your MRP file, and that's going to be bad. In fact, it may simply fail to import. So that's an important step. Now these coordinates are in latitude and longitude, so I'm going to select that. I'm going to specify that the coordinates coming in are lat long. My MRP is in a projected coordinate system, so my coordinates are going to get reprojected and then stored in that projected coordinate system when I import. So I've set everything up. I can hit OK, and it will now do the import for me. So the MRP has been created, it's computed statistics, it's generated the overview levels, and then it will display that MRP. So we'll come in here and choose our micro-leveled aeromagnetics with an equal area transform, and then you start to see the data values. So we have flight lines, and I can see that I've chosen the wrong coordinate system. Maybe it was zone 53, that survey, not zone 50. Otherwise, these lines would have been north, south, east, west. Too bad. So there's our input data set. Now, as I said before, that import will now be sitting on the menu, and you can go back to it. When I go back to it, I have the option to either restart. When I hit restart, everything goes back to 0. I can change anything I want, and I can rerun the entire import and replace the MRP file. Or I can come back in and I can augment the existing MRP file with more data. So you can see that the file that I've already imported, and I could have, of course, brought in many files. I could have brought in thousands at once. It's got a little star. That means it's already been imported. I can go and browse for some new files. They could be in a different format. I can then go and change the import parameters on our other dialog. So let me just do that. So go into, say, this one. Oops, sorry, I'm selecting folder. I want to select file. That one. So now I've got one file that's going to be imported and one file that's already been imported and will be ignored. I can now go back into my dialog for for the ASCII column properties and set it up for this particular file or this group of files, and that might be different. However, you have to make sure that the MRP file settings are identical. So you're going to want all the same bands in all the same order. Don't get that wrong, because it will screw up. And then you can run that again and add more points into that MRP file, which I won't do now. So that's a deeper dive into the multi-banded point import. So at the end of the day, what you get is you can take ASCII data in one file or in 50,000 files and import it. That ASCII data has to be essentially column delimited. It might be a CSV file where it's comma delimited, or it might just be in some kind of tab or space delimited columns. Those ASCII files can have a header on it, but they must all be the same. And you can import that data into an MRP file. You can reproject those coordinates on the way in. And at the end of the day, you get all those points stored in a way that they're spatially indexed. And you have statistics, and you have an overview pyramid of those points. So regardless of how many points you import, whether it's a million or a trillion, you'll be able to display those points immediately in ProRaster. You'll be able to grid them in real time at any scale in ProRaster, and you'll be able to work with them efficiently regardless of the size of the data set. And in our next video, we're going to be looking at how to grid this data using ProRaster Scientific. Thanks for watching.